very interesting places. The star does keep one face to this planet keeps one face to the star. You may think there are two poles, but there's a hot place and a cold place, but these are not the poles of rotation. Those are at right angles to the hot and the cold place, so it takes a little getting used to. And what's wonderful about these when it comes to life is that you have a very hot region directly facing the star, and as you go towards the terminator, the temperatures become less and less. So there's a tremendous range of temperatures, and this creates the opportunity for there to be somewhere a zone where the temperatures are suitable for life, where there will be liquid water and life can evolve. And the artist has shown this here in the form of lakes, which are forming at just the right place. And you can see the clouds tracing the streaming gases from the hot point to the cold point. You might call these stars Camelot. The star, if you're standing in any place on this star where the star is in the sky, the star never moves. The star never sets, it never rises, it's always in the same place. There is no night. So if you're a living thing there, you live in quite a different way as we live here. If you move towards the hot substellar point, you get warmer. If you want cold, you want to ski, you go the other direction towards the terminator, and you can have anything you want. And it's totally predictable. Now, just to make this even more interesting, something has been revealed in those last 40 years about our system, which reveals to us a phenomenon which we had not guessed, and it was revealed to us by the planet Mercury. Mercury is close to our sun, and people thought it kept one face towards the sun, just as the moon does towards the Earth. But in fact, radar observations made at Arecibo some years ago showed, to our surprise, that that is not the case, and that as Mercury swings by the sun, in a very elliptical orbit, by the way, each time it is closest to the sun, it presents an opposite hemisphere to the sun. This is called a resonance. It comes about because of Kepler's third law, for those of you who know that, which says that in an elliptical orbit, an object, as it approaches the closest point to the star, moves very rapidly. Now, it not only moves very rapidly, but what's important here is that as it gets close to the star, tidal forces become very strong. The tidal forces go as the cube of the distance of the star, an inverse cube. And this means there's a tremendous tidal force on the star as it zooms by, on the planet, as it zooms by the star. And what happens is that tidal force tends to make the star, or the planet, keep one face towards the star whenever it passes close to the star. And to do that, it must spin at such a rate that it's not in synchronous rotation. And in fact, in the case of Mercury, it turns out that the balance point, where the torques due to tides are average out to zero in the course of an orbit, occur when the object presents one alternate faces to the star, in our case the sun, each time it passes closest to the star. This could well happen to many, perhaps all, of the red dwarf planets, in which case there is no cold side to them. On each close passage, they will present an opposite hemisphere to their star, just as Mercury does. And this, too, will aid in evening the temperatures and making life possible. Now, that's important because for every sun-like star, there are almost 8 red dwarf stars. And so if now the red dwarf stars are perhaps more promising as abodes of life than the sun-like stars, it means the number of potential habitable planets has grown enormously in the galaxy. Now, this is a diagram that shows you how this works in a way. It shows you 2 of the newly discovered planetary systems superimposed on a diagram of our solar system. On the left is the system of 47 Ursae Majoris, which actually has 3 planets. One of them is very close and hidden in the image of the star in the center here. The planets are nearly circular, so this is very much like our system. On the right is the system of 16 Cygni. which has two planets, one in very close again and one of them far out, as you see, with a very elliptical orbit. This is the type of orbit that would lead to that phenomenon I just described to you of planets in the red dwarf stars presenting alternate faces to the stars they go by. But there's another point in showing you this, and that is that in the planets we have discovered, the great majority have very elliptical orbits, much more so than in our solar system. Now, that ellipticity is required to create the Mercury rotation phenomenon, but quite separately, it is evidence for phenomena happening in these systems which are very important. How do you get elliptical orbits when you start out with a disk of dust, as I showed you, where everything is rotating in very circular orbits? Well, what happens is objects collide with one another, and they make planets, and if you make enough planets, they will be orbiting in orbits close enough to one another that their own mutual interactions will perturb the orbits, alter them, so the planets don't follow the same orbits all the time. And one has shown with computers that given enough time, this alteration of planetary orbits can result in one planet crashing into another or making a close passage to another. And the end result is the destruction of a planet or, and this is what's really surprising, the ejection of a planet from a planetary system. So what you see here is an artist's depiction of the sort of event which created our moon. A very large planetary-sized object crashed into the Earth, actually, and ejected enough material that it became the moon. And that's how our system came about. But had that object narrowly missed the Earth, it could well have been accelerated by the gravity of the Earth to such a speed that it would escape the solar system. And in fact, the computer modeling shows that this must happen very often. In fact, most of the systems we have found have as many planets as they can hold, and what's left there are in elliptical orbits. And this suggests that more planets than they could hold were created, and some of the poor, unsuccessful ones have been thrown out of the system to travel in the intergalactic space forever.